Okay, welcome. Let's look at the next slide. Next example on annuity. Suppose you win the Publishers Clearinghouse $10 million sweepstakes. Now, sweepstakes will be similar to a lottery that we have here. So if you win the lottery, 10 million, for example. Okay, this 10 million is actually paid out this way. The money is paid in equal annual installments. Annual here means yearly. So we are back to years now, not month. Annual installments, $333,333.33 every payment per year over 30 years. So if you multiply these two, then you get 10 million roughly. This is 1/3 of a million roughly. Then you have over 30 years, therefore you have 10 million. So that's what is given out. But is it actually 10 million? Do you actually gain 10 million now? That's the question. Now you're told that if the appropriate discount rate is 5%, the interest rate here is 5%, how much is the sweepstakes actually worth today? So if you let's say you have this money now, and you want to arrange for $333,333.33 over 30 years. So how do you do that? Okay, so how can you do that? How much money do you need now? That's the question. So we can use the formula first. We can use the formula. One moment. We can use the formula. The formula is here. The present value of annuity is equals to the payment multiplied by 1 minus 1 plus 5. Okay, so this is the first element. This payment is known. This is the first known element here in this problem. The second known element is the interest rate, 5%. This is discount rate. Now this discount rate is per year. Because this is payment per year, this must be discount rate or interest rate per year. And it is over 30 years, the term. This is the third element, which is also known. This must be in years. 30 years, negative 30. So you get $5,124,150.29. So this is actually the worth of this payment that you receive over 30 years. It's only 5 million. So it's not actually 10 million. Even if you win 10 million lottery, it is only worth about slightly more than 5 million, just more than half, slightly more than half of the announced price amount. Why? Because this price amount is actually given over a period of time. It's not given in one shot, one go, in a lump sum. Okay, so if you have this much of money now, you can actually duplicate. You can invest this money at 5% per year for 30 years, and from that amount you can withdraw $333,333.33 per year for 30 years. Okay, and that will completely use up this amount. So what you receive now will be what you put in now, will be equal to what you receive over 30 years. Okay, so that is what is meant by this present value annuity example. Alright, let's move on. You can also use you can't see it here, you can also use the table. Let's move down a little bit so that you can see it at the bottom. Okay, the present value is you can use the table, present value annuity table. So you use this value here, the payment $333,333.33 multiplied by present value interest factor annuity 5% 30 years, or 30 periods, 5% 30 periods. So you look at the appendix table, table A3. Okay, you look for the column of 5%, and then look at the row for 30 periods. Okay, so the value is here 15.3725. So 15.3725 you multiply with $333,333.33, you get $5,124,166.62. Now this is an approximation. Why? Because it's rounded, this value here is rounded to 4 decimal points, and therefore you get a slightly different answer. This is a more accurate answer. Using the formula is a more accurate answer, as long as you don't round off any of the values here. Okay, you get a more accurate answer here. So this is an approximation, because the table gives you a value which is rounded to 4 decimal points. Okay, so you can use a table in this particular example, like we have seen in the previous example. Some problems you cannot solve using the time value tables given in the textbook, because one, the interest rate may not be available. Let's say 1.5%, it's not available. For example, if it is 5.75%, that interest rate is not available in the table. And some years, the periods, number of periods are not available. For example, 45, or 48, okay, like we have seen in the previous example, those are not available. So in those situations, you cannot use the table. So a formula would be better, in most cases. In fact, all cases you can use the formula, except one. We will see that later. Alright, let's move on to the next slide. Okay, so we'll skip this. Okay, you can go through this example on your own, buying a house. Okay, this example you can go on your own. This is another example of what you have seen earlier. So we'll skip that. Okay, you can try it on your own. Now, annuities on the spreadsheet. Okay, I have shown you this. Okay, therefore we'll skip this one as well. Okay, all right. Now we look at the quick quiz. We are coming to an end of the second part here in this chapter about annuities, particularly present value of annuity. We have some more to go in this part actually, but we just look at the present value of annuity when it's not known. Alright, so you know the payment amount for a loan. This is a summary question. So if you are able to answer this, then you have mastered whatever we have learned in this part. You know the payment amount for a loan, and you do not want you want to know how much was borrowed. Do you compute a present value or a future value? That's the question. So you know the payment amount. Okay, you want to know how much was borrowed. Okay, so this is actually a present value because you borrow now. Okay, we want to see what is the value of the payments that you make for a loan now. That is the amount that you borrowed. So it's a present value problem, not a future value problem. Okay, so let's apply this. The second point here, you want to receive $5,000 per month in retirement. Note that this is per month, not year. So this is, there should be a dollar sign here. It's missing. It should be $5,000 per month in retirement. You can earn 0.75% per month. Note this. This is also month. This is per month. This is per month as well. The payment and the interest rate, they coincide. It means they are in the same terms, and you expect to meet the income for 25 years. This is after retirement. Now this is in years, not in months. So you need to convert this to months, because the payment is in month, the interest rate is in month, so this must also be in months. So this is 25 times 12 months. So this will be 300 months. Okay, with that. So you need to convert this to 300 months. How much do you need to have in your account at retirement? Now, is this a future value problem or a present value problem? You might see the wording here. How much do you need to have in your account at retirement? This retirement is in the future, right? Presumably you have not retired yet. So this retirement is in the future. Just because this is in the future, you cannot say that this is a future value problem. It is actually a present value problem. Okay, present because the value is earlier than the payments that you wish to receive from your retirement savings. Okay, that's a key point. Because the value is earlier compared to the stream of payments that you want to receive after your retirement. Therefore, it's present value. You want to know what is the present value of this $5,000 per month that you want to take for 25 years or 300 months. So for this we use the formula. Okay, this is 5,000 multiplied by 1 minus 1 plus 0.75%. This is 1 plus 0.0075. You need to convert this to decimal. Raise this to the power of negative 300. Okay, you do this first. 1.0075. 1.0075. Raise that to the power of negative 300. You get that value. You minus 1. You minus that from 1. 1 minus that value. Then you divide this by 0.0075. This is 0.75%. Therefore, it's 0.0075. Once you get the value, then you multiply with 5,000. Okay, so you get this value here, $595, $808.11. So this you need to have at the beginning of your retirement. At the end of your work period, you must have this much, so that this amount, when you invest at 0.75% per month, okay, you can withdraw $5,000 per month for 300 months, and this will be completely used up, okay, at the end of the 300 months. So that's the idea behind this. Alright, let's move on to the next slide. Okay, now what we are going to do, we are into a new part here. We want to look at the same issue, the same problem, but we want to solve for the other elements which become unknown. So in a present value problem, okay, sometimes you want to determine the other elements which are unknown. For example, in this case, suppose you want to borrow $20,000 for a new car. You can borrow at 8% per year, okay, compounded monthly. So they tell you here, okay, the monthly rate is 0.66667% per month. Okay, why they give you monthly? Because your payment is monthly. If you take a 4-year loan, they tell you the term here, 4 years. What is your monthly payment? Okay. Now, what are the known elements here? The present value is already known, because you borrowed 20,000. In the previous example, this was unknown. You know the payment. But here you do not know the payment. Your monthly payment is not known. So there are 3 known elements here: the present value of annuity, which is 20,000. The N, which is 4 years, but this 4 years, because this is monthly. Okay, the interest rate is month, and your payment is monthly. Remember, you start with the payment is monthly, and therefore the interest rate must be monthly, and the term must also be in months. So therefore 4 years is actually 48 months. 4 times 12 is 48. Alright, so we know the N. We also know the R. The R is actually 8 divided by 12, which is 2 over 3, or 2 over 3, okay, percent, or this is 0.66667%. Therefore, if you change this to decimal, it will be 0.0066667. Alright, so we know all that. So now the unknown factor is the A, the payment. So it is actually the same formula. It's not different. This is the formula. It's the same formula as we have seen previously. The same formula we express in terms of A. Okay, just now the same formula was presented in terms of present value of annuity on this left hand side, but now we have annuity payment, the payment here. Okay, so you bring the present value of annuity to the right, you multiply with R, then you divide this by 1 minus 1 plus R raised to the power of negative n. So this is the formula. Alright, so you replace that. So present value of annuity is 20,000 here, 20,000. Multiplied by R is this, but I do not want to use this because this is rounded. I prefer using this 8% divided by 12, alright, so this is the full amount. Then 1 minus 1 plus R is 8% divided by 12, raised to the power of negative 48, which is 4 times 12. So you get a value of $488.26. So that's the answer. So every month